Hello, everybody. I hope you're doing well. Thank you for joining me once again. We're going to continue on sort of our Fryer journey as we confront ourselves with the 2015 version of the paper. The Fryer, of course, being the grade 9 written contest put out by the University of Waterloo. We're going to be covering the 2015 paper in these next few videos. So let's take a look at the contest itself. Alright, so it's got its standard sort of cover sheet telling us about the 75-minute time limit and telling us the light bulb questions just require a final answer and the full solution questions we need to actually write out our justification, we need to prove things that we claim, and we're marked on completeness, clarity, and style. Okay, each question on the contest worth 10 marks. Always a good idea to read through this portion. It does change every once in a while. So you got to keep up to date on that. As I usually try and warn you guys, try the contest ahead of time. It is on the CEMC website. I will put a link down below. And try it. Don't look at their solutions until you have tried the contest. And then, you can watch these videos and try their solutions. But you should really try the contest ahead of time. But I always harp on that. So why don't we just get into it with the very first question. Okay, so question number 1. A company builds cylinders. Its Model A cylinder has radius 10 and height 16. And that's in centimeters. So here we have a nice little picture of what a cylinder looks like. That's what the height is, that's what the radius is, and they give us the formula for the volume of the cylinder. So without even looking at the question, I guess we're probably going to be computing some volumes. Alright, A part. It's a light bulb question, so we just need a final answer, but as usual, we'll write down some justification so that you guys can know how it's done and how to get part marks. So A part, what is the volume in cubic centimeters, so centimeters cubed, of a Model A cylinder? Okay, not that difficult. We were given the formula we need for the volume. And we know the radius is 10 centimeters and the height is 16 centimeters, so really, this just amounts to plugging it into the formula. So it's pi r squared times the height. If you have any figure of a common base and it has been raised up a certain amount to create a three-dimensional solid, you just do the area of the base times the height. Alright, so pi, well, pi is pi. We know what the radius is, that's 10 centimeters. And we want to square that, and then the height, I believe, was 16 centimeters. That's pi, and then we have 100 centimeters cubed times 16 centimeters. And so we can get our final answer of 1600 pi centimeters cubed. So what we would put in the little box provided with the light bulb, I would put the 1600 pi, because it says volume in centimeters cubed, so they're already telling you what units. You just need to provide the total amount. So we'll just double check we got the dimensions right. Height 16, radius 10. Congratulations, we're done part A. Okay, on to the B part of the question. The company also builds a Model B cylinder, having radius 8. Each Model B cylinder has the same volume as each Model A cylinder. What is the height in centimeters of the Model B cylinder? Okay, well, we just figured out the Model A's volume. So we want to set that equal to the Model B's volume. We know the radius. We're asked to determine the height. So we know Model B and Model A have the same volume. And so we know that that's going to be 1600 pi centimeters cubed. So now we use the formula for the volume of a cylinder. the radius of model B is given to us. The only thing we don't know is h. Okay, so 1600 pi. You can drop the units for your work if you want to. I mean, I'm certainly keeping them longer than I usually do. So rearranging this to solve for h, we divide both sides by 64 pi centimeters squared. Okay, the pi's will cancel out, the centimeters squared and the centimeters cubed will give just centimeters, so we know we've done the correct things, at least in terms of dimensional analysis. And you can either work it out on your own, or you can plug it into a calculator and get 1600 over 64 is going to be 25. Alright, so we have a height of 25 centimeters. That solves B part, nice and simple. Now C. So this one, the little handwriting on a piece of paper suggests we're going to have to actually write our solution, which is not going to be any different than how we usually behave in these videos, but it bears repeating that you need to watch for these symbols and know when you need to write and when you don't on the contest. So the company makes a rectangular box called Box A that holds 6 Model A cylinders. I wonder where they got the name Box A. The cylinders are placed into the box vertically and tightly packed as shown. Determine the volume in centimeters cubed of Box A. Alright, so we need to justify our answers here. Well, I always like trying to draw a picture, so we'll do that. Not the best, but not the worst. So we're asked for the volume of Box A, so what do we need? We need to figure out the dimensions. So the height of the box is the same as the height of the Model A cylinder. And so what was that? Well, that was 16 centimeters. Okay, so that was the easy part. Now we need the length and the width of the box. So if we were to look at the box directly from on top of it, what would we see? Well, we'd see sort of 6 circles inside a rectangle, and the circles are just touching the sides of the rectangle, and all the circles are the same size, they have the same radius. Right, if we wanted the width of this box, well, the cylinders are so tightly packed that they're all tangent to each other. and if we were to add up 2 diameters and 3 diameters, we get the width and the length. Well, we don't know the diameters, but we do know the radii. That's why I've included the centers here. So we have 1 radius, 2 radius, 3 radius, 4 radius. That'll give us the width of the box. And 1, 2, 3, 4, 5, 6 radii give us the length of the box. So we get 40 centimeters for the width, and our length will be 6 times 10 centimeters, which will be 60 centimeters. And all we have to do is multiply these along with the height, which we figured out last time. And we get, what do we get? Plug that in on our calculator. 38400 centimeters cubed. Okay, so that's C part, and we actually wrote down our explanation of how we got the length and the width, which is what they're looking for. Alright, D part, we're back to just final answer. The company makes another rectangular box called Box B. Let me guess, it holds Model Bs. Box B that holds 6 Model B cylinders. The cylinders are placed into the box vertically and tightly packed, just as was shown in part C. Okay, so basically the same thing, just with different types of cylinders. State whether the volume of box B is less than, greater than, or equal to the volume of box A. Okay, so they're looking in the little box provided for the light bulb question. I guess they're asking us to make a little statement. So, the same reasoning will allow us to get the height and width of box B. And the length, sorry. So this time it's 25 centimeters. That's what we figured out. We use the exact same work that we did last time, and we can figure out the length and the width. It's still going to be, the width is 4 times the radius. It's just a different radius this time. It's 8 centimeters rather than 10. So that gives us a width of 32 centimeters and a length of 48 centimeters. So that's 48 times 32 times 25. And we can work that out as well. 48 times 32 times 25. And once you know it, it's 38400. So it turns out the volumes are equal. Okay, and that's what we were asked for. We were just asked for our final statement there, that the volumes of the boxes are equal. So a good introductory question, lots of light bulbs, which is something we like to see. And yeah, it's about that all there is to say. It's a good start to the 2015 paper. Join me in the next video, and we'll take a look at question number 2.